Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to mechanics and the chapters of mechanical actions, equilibrium of a body and Archimedes upthrust. This exercise was a previous one in the brevet exams in 2002 first session, third exercise. The title of this exercise is determination of the density of a solid. In order to determine the density rho of a small metallic block taken from the ground, we consider a spring balance having its upper end fixed to a support and a water container. Take G is equal to 10 newtons per kilogram, which means that we are performing this experiment on the surface of the Earth, and the density of water, let's denote it by rho W here because rho is being for the small metallic block, is given by 1000 kilogram per meter cube, so the density already is given in the SI. Now number 1, in the first experiment we suspend the block from the free end of the spring balance. The system spring balance block is at equilibrium in air, so this is important. The spring balance indicates 5 newtons. Deduce from this indication the magnitude of the weight and its mass. So first, let's start by the first part, which is the magnitude of the weight. So always the spring balance measures the weight. So here we have two weights, either the real weight or the apparent weight. Because it's being suspended at equilibrium in air, then the spring balance indicates the real weight. Then let's say, since the suspended object is in air, at equilibrium, then the spring balance indicate its real weight, and in this case the real weight is given by 5 newtons. And in the same part they are telling me to calculate its mass, knowing that the real weight is the weight which is given by m multiplied by g. So now we can determine the value of m. Then w is equal to m multiplied by g. We are interested in determining the value of m. So constructing the triangle of this formula, here because we have multiplied, then w will be at the top, m and g at the bottom, knowing that we are interested in determining the value of m, which is given by the real weight divided by g. So the real weight is given by 5 divided by the value of g, which is given by 10. So plugging this fraction on the calculator, the value of m will be given by 0.5. Since everything in the SI, so the value of m will be in the SI, which is kilograms. So the mass of this small metallic block taken from the ground is given by 0.5 kilograms. So here let me say that m is equal to 0.5 kilograms. Now notice that the aim of this exercise is to determine the density of this small metallic block. And the density is usually determined using mass divided by volume. And from the first experiment we have determined the mass, so we expect from the second experiment to determine the volume V of this block. Now let's see. In the second experiment, the block being still suspended from the free end of the spring balance is completely immersed in the water. So what does completely immersed mean? This is important. Then in this case the immersed volume is equal to the total volume of the block. So if we are able to determine the immersed volume, then we are done. At equilibrium, the indication of the spring balance becomes 3 newtons. This difference in the indications, they are telling me of the spring balance is due to the Archimedes upthrust force exerted by water on the block. Then whenever we have a liquid, in particular water, then the solid, the metallic block will be directly subjected to the Archimedes upthrust force in addition to the weight. Part A specify the line of action and the direction of F, always opposite to the weight. F acts vertically upward, so in this case the line of action is vertical, and the direction is upward. Now part B, determine the magnitude F of F factor. So here we can determine the value of F using its definition that F is given by the real weight minus the apparent weight. We know the value of the apparent weight. which is given by 5 newtons. And here, because the solid S being at equilibrium in water, so what does this indication represent? Always the spring balance measures the weight, and in this case it is the apparent weight, because the metallic block is inside a liquid, which is the water. So here first let's justify that the apparent weight is given by this reading. So let's say, since the suspended object so let me say that this is part B. Let me erase this. Is immersed in a liquid. At equilibrium. Then the spring balance indicates its apparent weight. So in this case the apparent weight is given by 3 newtons. The real weight was given by 5 newtons, and the apparent weight is also given by 3 newtons. And now we are ready to calculate the magnitude of F by referring to its definition, which is given by F is equal to the difference between the indication of the two spring balance. So the real weight minus the apparent weight, 5 minus 2. Both the real weight and the apparent weight are expressed in newtons. So sorry, minus a 3. So both are expressed in newtons, so the value of F will be in newtons, which is the SI. Then the force exerted by water on the small metallic block has a magnitude of F is equal to 2 newtons. Now in part C, calculate the volume V of the block. Knowing that we have already determined the magnitude, we know that the volume and the magnitude are related via the following formula, that F upthrust is equal to the density of the liquid times the volume of the immersed part times G, knowing that we are interested in determining VI. Constructing a triangle for this formula. So here, because we have multiplied, and F will be at the top, rho L, VI, and G at the bottom, knowing that we are interested in determining the value of VI. Now VI is given by F upthrust divided by rho L multiplied by G also. So F upthrust, which is denoted by F, and the density of the liquid is denoted by rho W multiplied by G. Now the value of F is given by 2, the value of rho of water is given by 1000, and the value of G is given by 10. Plugging this fraction on the calculator, then the immersed volume is given by 2 times 10 to the power minus 4 meter cube. Why meter cube? Because F, rho, and G are in the SI, so the value of VI will be in the SI, which is meter cube. So what does VI represent? VI represent the volume of the immersed part of the metallic block. But notice that the required volume is the total volume V of the block. So it's left to say that since this metallic block is completely immersed in liquid, in water, then VI is equal to V. And let me write this important statement here. Since the metallic block is completely immersed in the liquid. So in this case, the liquid is represented by water. Then we have the total volume of the block, which is denoted by V is equal to the immersed volume, which is given by 2 times 10 to the power minus 4 meter cube. So the volume V is given by 2 times 10 to the power minus 4 meter cube. Now number 3, deduce from the above two experiments the density rho of the block. And by deduce it means that we need to use the previous parts. No previous parts here in number 3, which means that we need to use the results of both experiments. The result of the first experiment was the mass, and this is the result of the second experiment, which is given by the volume. And we know that the density by definition is the ratio mass over the volume. No need to construct a triangle. 0.5 in the SI divided by 2 times 10 to the power minus 4 in the SI. Then the density is given by 2500. Since both the mass and the volume are in the SI, so the value of the density will be in the SI, which is kilograms per meter cube. So the density of this material is given by 2500 kilogram per meter cube. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.